Welcome, students. Today's video is on literal equations. In other words, we're going to be solving multivariable equations for one single variable. These equations will typically be found in most real-world situations. For instance, anytime I've calculated area or perimeter, I've dealt with length and width, and those are often separate variables. Our steps are to locate the variable we're solving for. We'll distribute, just like we did with all equations. We'll combine like terms on the left side and then on the right side, and then we'll start combining like terms across the equal sign. Just like we did with all regular one variable equations, we're going to use opposite operations to move things around. Example 1, I'm going to show you a simple one variable equation like we've solved in the past. In this case, 4 is equal to 5x minus 6. To solve this one, I want to get x by itself. So my x is currently located right there. I see that 5 and 6 are standing in my way. I'll add 6 to both sides. This will give me 10 is equal to 5x. Then I'll simply divide both sides by 5, and I get an answer of x is equal to 2. Now, notice in this equation now, my 4 has been replaced with a y. Again, my steps will be the same. My result will just be a little different. If y is equal to 5x plus 6, again I'm solving for x, so I will add 6 to both sides. Now, I cannot combine y and 6, so that just stays y plus 6. Remember, combining like terms, I can only put the same exact terms together. Since y and 6 are not like terms, they have to stay separate. Then that is equal to 5x. Again, I want to get x by itself. Just like I did in the left equation, that means I just need to divide it. So I end up with a result of x is equal to y plus 6 over 5. And I have no need to simplify or go any further. This is my final answer. Notice the steps were the exact same, but the result was just a little bit different because I didn't have a y. Now we're going to try another one just like that. Solving on the left, notice I'm solving for y, which is located right there. First step is get rid of that 12, so I'll subtract it from both sides. That gives me 2y is equal to negative 30. I can divide both sides by 2, and I get y is equal to negative 15. Looking at the next one, as I go to start solving this, again, I'm solving for y, so that's what I want to get alone. I want to move this whole ax term. Since it's positive, and I don't really know anything else about it, I'll just subtract it from both sides. Just like if that was the 12 from the example before. Then I have by is equal to c minus ax. Again, I want y totally alone. On the left it was a 2, this time it's a b, which I don't know, but I can still divide it away. Then I end up with a final result of y by itself, which is what I wanted, equals c minus ax all over b. Again, literal equations are just giving me a formula to work with. This way, any x I plug in or any y I plug in will give me the other variable. Example 3. Again, I'll separate my two sides. To get x alone, first I will multiply by negative 2. That will give me positive 20 on the left equals x plus 3. I'll subtract 3 from both sides, and I end up with 17 equals x. Now, when I look at my equation on the right, a is equal to x plus y over 2. Again, I want to get x by itself. Notice how similar this looks. So, again, just like I did on the left, I'll start by multiplying by that 2. That gives me 2a is equal to x plus y. Now to get x alone, I just have to subtract that y away. So I end up with 2a minus y equals x. And that's my final answer. Example 4. On the left side, if I'm solving for y, I'll subtract 12 from both sides. That will give me negative 4y equals 8. I can divide both sides by negative 4 and figure out y is equal to negative 2. Looking at the equation on the right side, again, solving for y. Looking at how similar this is, now I just have an x attached to my 12. So my steps will look almost identical. I'll subtract 12x, the whole term, away. Then I have negative 4y equals 20 minus 12x. I need to divide both sides by negative 4 to get y alone. So y is equal to, and in this case, both terms are divisible by that 4. So 20 divided by negative 4 will give me a negative 5. And negative 12 divided by negative 4 will give me a positive 3x. I'll end up with y equals negative 5 plus 3x. Example 5. On the left side, I'll start solving. Again, I locate my variable. This time I do have to distribute. So I'll take care of that step first. So y minus 3 stays the same on the left. And on the right side, 2 times 5 will give me 10. Minus 2 times 7 is 14. Again, I'll combine like terms. Y minus 3 will stay the same on the left. And on the right side, this will become negative 4. I can add 3 to both sides and get y equals negative 1. Now if I look at the equation on the right side, again, I'm trying to solve for y. So first step is just to distribute. Y minus 4 stays the same and is equal to 3x minus 18. Now, since I'm still trying to get that y alone, the only thing standing in my way is that negative 4. So I'll add 4 to both sides and get y is equal to 3x minus 14. That is my final answer. Try the back side of this page on your own. Answers will be posted in the room for you to double check your work. Thanks for watching.